Hi learners! On this video lesson, you will learn what a pyramid is, its properties, and how to get its volume. Determining its volume is demonstrated and explained in details to let you understand the concept easily. Real-life applications of pyramids are shown, thus making the concept relatable and meaningful. Strategies in analyzing and solving problems related to the topic are showcased to let you gain an understanding on how these are done so that you will be able to successfully answer geometry problems similar to these in the future. If your lesson is on solid geometry, particularly on pyramids and their volume, or if you have an assignment on this topic, or if you are preparing for a test in math or a test in geometry in particular, or you are someone who is interested in learning math, then this video is for you. The most famous pyramids in real life are the Great Triangular Pyramids of Giza, the Square Pyramids of Egypt, and the Louvre Pyramid in Paris, France. We also have rooftops of buildings and houses, floor signs, radios and cell towers, camping tents, etc. that are built and designed having the shapes of pyramids. As you see, pyramids are 3D objects or solids having one base which is a polygon, like a triangle, a rectangle, or a pentagon, etc., and lateral faces that are triangles that converge to a single point at the top. Pyramids are oftentimes sitting on their base as what we have here. Look at the figure that we have here, learners. This is a rectangular pyramid. It has only one base, which is a rectangle with its center. Because there are 4 sides of the rectangular base, there are also 4 lateral triangular faces. The triangular faces converge at a common point at the top. This point is the vertex or the apex of the pyramid. Now, when the line connecting the apex and the center of the base is perpendicular to the base, we say that the pyramid is a right pyramid. For this type of pyramid, the distance from the apex to the center of the base is the height of the pyramid. We also have another height here, which is the slant height. This is the height of each lateral face. On this video lesson, we will only focus on right rectangular pyramids and right triangular pyramids. Again, these are the pyramids whose apex at the top is directly above the center of the base at the bottom, and the line connecting the apex and the center is perpendicular to the base. Look at this right triangular pyramid, learners. How many lateral faces are there on this pyramid? You're correct. There are 3 lateral triangular faces. This is because its base, which is a triangle, has 3 sides. Again, for this right triangular pyramid, the height is the distance from the apex to the center of the base, while its slant height is the height of its lateral face. You must have noticed that pyramids are named after their bases. If the base is a rectangle, the pyramid is a rectangular pyramid. If the base is a triangle, then it is a triangular pyramid. If the base is a square, the pyramid is a square pyramid, and so on. There is another thing that you need to remember, learners. When the base has sides that are equal in length, like a square, equilateral triangle, etc., the lateral triangular faces are congruent. Now, how is the volume of the pyramid determined? This is our goal in today's video. On the previous video entitled Solid Geometry, Prisms, Volume, and Cross-Section, the volume of the prism is determined with the formula B times H, where B is the area of the base, H the height of the prism. For the pyramid, its volume is exactly 1/3 the volume of the prism having the same base and height. That is, 1/3 the product of B and H, where B is the area of the base of the pyramid and H is the height of the pyramid. If the pyramid is a rectangular pyramid, B is the area of the rectangular base, which is length times the width. Thus, the volume of the rectangular pyramid becomes 1/3 times the product of its length, width, and height. If the pyramid is a triangular pyramid, B is the area of the triangular base, which is 1/2 the product of the height of the triangular base and the base of the triangle. Thus, the volume of the triangular pyramid becomes 1/3 times 1/2 the product of the height of the triangular base and the base of the triangle times the height of the pyramid. Multiplying 1/3 and 1/2 gives us 1/6. Thus, the volume is 1/6 the product of the height of the triangle, the base of the triangle, and the height of the pyramid. Take note that the volume is in cubic unit of length, like cubic meters, cubic feet, cubic inches, etc. The justification to the formula for the volume of the pyramid could be done by conducting an experiment to show that the volume of the pyramid is only 1/3 the volume of the prism. This would be a good challenge, learners. You can demonstrate this in class using water and 2 containers, one having the shape of the pyramid and the other one a prism. Just make sure that the containers, the prism and the pyramid, have the same base, same shape and area, and the same height. Okay, let us work on this sample problem so you will know how to do it. Here's the problem. Your shop is designing new souvenir items for an upcoming anniversary celebration. One of it is a miniature pyramid. The shop is going to use plastic polypropylene, PP, for the material for the following reasons: affordability, versatility in shaping, color, and resilience to breakage. If the miniature pyramid has a square base with sides 3 inches and height of 5 inches as shown, what is the volume of the PP material needed in cubic inches to make one souvenir? Option A, 9 cubic inches. Option B, 15 cubic inches. Option C, 22.5 cubic inches. Option D, 45 cubic inches. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What is asked in the problem, learners? Okay, here we are asked to find the amount of PP material needed in cubic inches to make one souvenir. What are given? We're given a figure of the miniature pyramid with its dimensions. Okay, since we are asked for the volume of the miniature pyramid, we will need the formula for the volume of the pyramid, which is 1/3 the product of the area of the base times the height of the pyramid. Since we have a square base, and remember that a square is a special rectangle, the volume becomes 1/3 times length times width times the height. Now, let us label the other sides of the base of the prism and identify what these values are so it would be easy for us to plug in the values later. Let's go. Plugging in the values, we have now multiplying 3 inches, another 3 inches, and 5 inches gives us 45 cubic inches. Dividing 45 cubic inches by 3 gives us 15 cubic inches. So what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option B. Therefore, the amount of PP material needed to make a single miniature pyramid is 15 cubic inches. That was easy. Okay, let us move on to sample problem 2. Here's the problem. For Andy's next project, he's going to mold the clay into a triangular pyramid with equilateral triangle as its base, having a side of 3 feet and height of 5 feet as shown. Part 1. How much clay in cubic feet will Andy need for his project? Round your answer to the nearest tenth of cubic feet. Option A, 6.4 cubic feet. Option B, 6.5 cubic feet. Option C, 38.9 cubic feet. Option D, 39.0 cubic feet. Part 2. The clay is sold in pack of cubic foot. If each pack costs $1.75, how much will it cost Andy to purchase the clay for his project? Option A, $11. Option B, $11.38. Option C, $12. Option D, $12.25. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What are asked in the problem, learners? Okay, here we are asked to find two things. First, we are to find the amount of clay that Andy will need in molding the triangular pyramid to the nearest tenth of cubic feet. And second, we're to find how much will it cost Andy to purchase the clay for his project. What are given? We're given the figure of the triangular pyramid with its dimensions. The problem also states that the triangular base is an equilateral triangle. Okay, so we start by doing part 1 first. Since we're asked to find the amount of clay that Andy will need in molding the triangular pyramid, then we have to have the formula in solving for the volume of the triangular pyramid. Let us have the formula. By looking at the formula and the given figure, the base of the triangle and the height of the pyramid are known, but the height of the triangular base is not. So, we have to solve for the height of the triangular base first. A discussion on determining the height of the triangle is in the video lesson entitled Triangular Prisms, Total Surface Area. You can check on it, and the link is down below. Okay, let us look at our triangular base first. The problem states that the triangular base is an equilateral triangle. So all the sides are equal in length. Do you agree? Now let us draw the height of the triangle. Remember that the height of the triangle forms a right angle with the base of the triangle. So let's go. Look at the figure, learners. With the height drawn, we can now see two right triangles on our figure. Do you see them, learners? Now, height h divides the base into equal lengths. Thus, half of it is 1.5 inches. Okay, let us focus on the right triangle on the right side of the figure. We will label its sides with A, B, and C. Let's go. Note that height h of the triangle here is now labeled as A. Because h is now a part of a right triangle, we can now apply the Pythagorean theorem in solving for its value. Here is the Pythagorean theorem formula, where C is the hypotenuse, and A and B are the legs, the other sides of the right triangle. Plugging in the values, we have squaring 3 feet and 1.5 feet gives us 9 square feet and 2.25 square feet. Subtracting 2.25 square feet from both sides of the equation gives us 6.75 square feet. Now, putting h squared on the left side of the equation and the rest on the right side, we have h squared equals 6.75 square feet. Getting the square root on both sides gives us 2.598 feet. This is the height h of the triangular base. With the height of the triangle known, we can now solve for the volume of the pyramid. Plugging in the values, we have multiplying 2.598 feet and 3 feet and 5 feet, we have 38.971 cubic feet. Dividing 38.971 cubic feet by 6 gives us 6.495 cubic feet. Now, rounding off to the nearest tenth gives us 6.5 cubic feet. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option B. Therefore, Andy will need 6.5 cubic feet of clay for his project. Okay, so we move on to part 2. Here, we are to find the cost of clay that Andy has to purchase for his project. From part 1, we found that Andy will need 6.5 cubic feet of clay for his project. But since the clay is sold in packs, where each pack is 1 cubic foot, Andy has to buy 7 packs. Can you follow, learners? So, to get the cost of 7 packs of clay, we multiply $1.75 and 7. Do you agree? This gives us 12.25. So, what is our answer, learners? Is it option A, option B, or option C, or option D? Okay, so the answer is option D. Thus, Andy will need 6.5 cubic feet of clay, and it will cost him $12.25 to purchase the clay for his pyramid project. That was again easy. There you are, learners. I hope you acquired lots of learnings in today's video. Let us summarize what we have learned today. We have learned that, first, pyramids are 3D objects or solids having one base, which is a polygon like a triangle, a rectangle, a pentagon, etc., and lateral faces that are triangles that converge to a single point at the top, which we call the apex. Second, the volume of a pyramid is exactly 1/3 the volume of a prism having the same base and height. That is 1/3 B times H, where B is the area of the base of the pyramid and H is the height of the pyramid. Third, the unit of measure for its volume is in cubic unit of length like cubic meters, cubic feet, cubic inches, etc. Fourth, when solving a problem, you must read it and may read it several times when needed to know what you're looking for, to determine what are given, and to figure out how the given information help find what you are looking for. Fifth, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve a problem. There you are, learners. Hope this video helps. That's it for now. If you have any question, leave a comment below and do not forget to subscribe, like, and share this video to your peers so others will learn too. Bye.